welcome to my little stream. I'm Gloria from Noble. Today, let's share some information about 3D printing. If you have any questions, feel free to ask in the comments. And you can leave your words if one and let me know what's your questions. So, yeah, of course, don't forget to follow me. Okay, next, let's show our topic about 3D printing. Maybe someone will want to know what is 3D printing, and let's show for you. 3D printing is a revolutionary technology that creates objects by joining the materials layer by layer from 3D model data. So it's generally referred to as additive manufacturing, while part geometries are adapted by fusing with the previous layer. 3D printers deposit materials in a pre-programmed pattern to realize the layer-by-layer process by following the instruction and sent by a computer. So someone will know how do I choose the exact 3D printing technology for my parts. A specific 3D printing process may be suitable for some applications. You are expected to consider some essential factors such as material requirement, physical or visual characteristics, technology and compatibility like accuracy and part size. So what should be considered in 3D printing? There are large quantities of different processes for 3D printing, but each process has its specific materials and design requirements. Therefore, it's worthwhile to understand all key design factors related to all 3D printing process. Next, what are the applications of 3D printing? Our 3D printing is commonly used in many industries for repair, prototyping, and production, like aerospace and automotive, uh, consumer goods, and special machinery, healthcare and medical, and architecture and construction industry. What autonomy of a 3D printers and how to get started with 3D printing. Three-dimensional printer is a powerful technology for creating unique items with complicated geometry, serving various industries ranging from medical and automotive to defense and aerospace. What's the difference between MGF and SLS? MGF and SLS are two industry 3D printing technologies. Both of them belong to polymers and powder bed fusion. The main difference MGF and SLS is the similar heat source. We have summarized the main difference by comparing them in the fabrication process and accuracy, materials, cost, and leading time to help you distinguish MGF and SLS more clearly. About CNC machining and VS 3D printing. Hello, welcome to my live stream. About CNC machining is the most common extractive and manufacturing technology. It starts with a solid block of raw materials and utilized various shape, routing, and cutting tools to remove material. In order to achieve required final shape with high tolerance, CNC machining is widely applied to manufacture low and medium and high value production. It provides excellent repeatability and high accuracy and various surface finishes with wide range of metal and plastics. 3D printing or additive manufacturing produce parts by several layers of material aiding. It doesn't need any special tooling or fixtures. The process can be divided into SLS or FDM for plastic and DMLS for metals. So perfect technology selections. There are several simple guidelines for manufacturing process decision between CNC machining and 3D printing. As we know, any parts can be produced with limited effort by subtractive, which should select CNC machining. Otherwise, 3D printing can make sense in following case. The first one is traditional methods are unable to produce, and especially for high complex geometries. The second is fast run turnaround time is critical. And the next is low cost is essential, especially for small value less than 10. Okay, the last one is materials are not easily to machine, like super alloy or GPU. CNC machining is able to provide higher dimensional accuracy and better protests in each dimensions, while in small value production, its cost will be higher. In high quality production, neither CNC machining nor 3D printing can be cost competitive option and the traditional forming technology like investment casting, injection molding, and are more economic. About, about dimensional accuracy and CNC machining provides higher tolerance like excellent repeatability for different part size. In reason of cutting tools shape, internal corners have reduced, while external surfaces can be machined at sharp edges and thin. Different 3D printing system has various dimensions accuracy. All 3D printers can produce parts with good tolerance. Once you need tire and clearance, we can print oversized dimensions, then machined in post-processing operation. The minimum wall thickness of 3D printing is limited by and a factor size such as nose and diameter in FDM, laser spot size in SLS. Since 3D printers parts are created layer by layer, it is visible to see layer lines in parts, especially on combined surface. About material, since it is widely applied for metal machining, it also can be used for similar plastic and acrylics and softwoods and wax machining. And CNC machining parts have great mechanic and similar properties, while fully ISO certified common CNC materials. They have plastic like ABS and PET. About metal we have aluminum and stainless steel and brass. About 3D printing is meaning applied for plastic, less extent for metal 3D. 3D printing materials are wide with different physical properties, TPU and superalloy, always manufactured with 3D printing technology and common 3D printing materials. There were some as CNC machining, like plastic we have ABS and ASA and PLA. About metal, also we have aluminum and stainless steel, and so on. So next, in CNC machining design, we should consider some design limitations, such as tool access and clearance, holding and molding points, and inability of square corners manufacturing. In this situation, there are some geometries cannot be produced CNC machining, even with 5 actual CNC machines. For such features, hello, welcome to my live stream. Today, I'm introduce some information about 3D printing. If you have any questions, don't don't ask me, and I will swallow the answers for you. Let's begin. Next, about the even with 5 actual CNC machines, for such features, we need to rotate parts direction. This will aid the positioning time and label time in process. In some cases, customer goods and fixtures will be needed. All those items will increase the final cost. 3D printing, comparing to CNC machining, has few geometry limitations. Support structures are required in many technologies, which will be removed in post-processing. The ability of high complex geometries production is a key strength of 3D printing. So manufacturing process in CNC machining, operators or engineers will consider tool selections like spider speed and cutting path, and path positioning at first. All those factors will impact final parts quality and process time greatly. This manufacturing process is labor intensive, and in reason of all set up a menu after machining process, those components are ready for post operations. In 3D printing, operators only need to prepare the digital file with orientation and aided support, then send it to printing machines, which require little human intervention and has once printing finished, we need manual cleaning and post-processing. About post-processing, there are various post-processing methods for CNC machining and 3D printing parts. In order to improve parts functionality and essential acts and most common post processing and technology including like CNC machining, like band plastic and anodize and powder coating. So what about 3D printing? We have medium blasting and sanding and polishing and metal planting. Next, we need to, so how about the technology selection experience? We have to follow the rules to select the right technology for your parts production. The first one is CNC machining is most suitable for medium to high value production, within 1 to 500, with simple geometries. The second is 3D printing is best for low quality and complex geometry. So if you just one piece or two piece, the 3D printing is a good choice for you. And we have good at 3D printing. So our notebook is your good choice for you. The next is for metal parts since CNC machining is more competitive with geometry's limitations. Next, once quality is more than 500 parts, other forming technologies are more suitable. Yes. So maybe someone will curious about what's the advantages of 3D printing. So next, I will show you 3D printing confers great benefits for making a prototype of the products, especially in the manufacturing field. It creates innovative possibility for the manufacturing of small batches, one-offers, and functional prototyping in increasing product active and efficiently, so while saving time and money. Each 3D printing process has its specific benefits as well as its limitations compared with other processes. 3D printing is advanced manufacturing technology for complex parts. It can create parts layer by layer at one time. Their mass has various advantages over traditional manufacturing technology like CNC machining, injection molding, or die casting. Although 3D printing is unable to replace traditional mass, there are many applications 3D printing can provide quickly production with high accuracy from functional materials. About speed, 3D printing as an additive manufacturing method has one main advantage of speed. It can produce complex parts in hours from a CD file. This advantage is the rapid verification and development of design ideas. As in past, it will take days or weeks to get a prototype. Additive and manufacturing can deliver a role model for designers well within hours, while 3D printers will take longer time to print parts. The ability of functional end parts production at low or medium volume will offer time saving compared to traditional manufacturing techniques. As injection molding leading time is at least last week. One-step manufacturing. The biggest concerns for every designer is how to produce a part in most effective way. In traditional manufacturing technologies, there are a large number of steps to follow. Those steps also affect the final quality and the manufacturing ability of the design. For customers steel bracket, traditional manufacturing months will start with a 3D model. Once the design is confirmed, steel materials will be cut into suitable size profile, then clamp those profiles into position and weld them for form the bracket one by one. Polish weld to a good surface finish, drill hole on suitable position, and finally the bracket is sandblasted and primed and printed for better appearance. While additive manufacturing machines can finish this in just one step, there is no interaction from operators in manufacturing process. Once the design is finished, we just need to upload it to the machines and printing in one step for a few hours. It can reduce the dependence to different production months and provide greater control of final products. So the key talks about some customer will pay attention to the cost, like manufacturing cost can be divided into three categories, and like machine operation cost and material cost and labor cost. 3D printing at low value production is, significant and competitive comparing traditional manufacturing methods. It is cheaper than other alternative methods for protection with form and fitness with verification, such as injection molding, and as value increasing, traditional techniques become more and more cost effective, and the high setup costs are justified by large value production. About machine operation costs, 3D printing technology will consume amount of engineering to produce one single part, but for complex geometries parts, it will give rise to higher efficiency and turnaround. In this process, machine and operation cost has the lowest contribution to the overall cost. Material cost. The material cost varies significantly for different 3D printing technologies. The material for additive manufacturing is difficult to make a qualified comparison with traditional methods. Material cost is the main contribution to part productions. About the labor cost, 3D printing has a low labor cost in manufacturing process. It's paid post-operation, and operators' major works is printing a bottle on 3D printer. Then the machine will follow an automotive process to finish part productions. Comparing to traditional methods, where high-skilled machinists and operators are required, the labor cost for 3D printing is nearly zero. 3D printing has nearly no restriction. Once comparing to traditional manufacturing process, as components are produced layer by layer and design requires like draft angle, undercuts, and tool axes are not applied in 3D printing design, although there are some restrictions on the minimal size and feature. Most of the limitations are how to optimize printing orientation, reduce support dependency, and filling likelihood. They will increase design freedom and enable complex geometries creation. 3D printing alone not only more design freedom, but also complete customization design, as current 3D printing always produces a single part at one time. It is the most suitable way for one-off production. The conception is widely applied in medical and data areas, such as customer uh, prosthetic and implants and detailed others. Additive manufacturing allows cost-effective single production of customer parts. 3D printing will not only suitable value of material to produce a part, in most processes, raw material can be recycled and reduced in next production. So there are very little materials waste. Well, subtractive manufacturing methods such as insemination or turning will remove amount of materials from raw blocks. Those result to high value of material waste. A fit prototype will cost the designer time and money. A small change in models or fabrication months will impact final cost significantly. 3D printing can produce prototypes before expensive investment equipment such as models, judges, in order to verify the design and eliminate the risk, building confidence before large mass production. While the low-cost metal parts production by 3D printing, metal parts are always produced by investment casting technology. However, there is an issue of modern cost. In order to produce large metal parts with very low cost, we applied FDM technology to create castable patterns, which cannot be created by traditional manufacturing technologies, with various features. In this article, and now the metal parts manufacturing in low-value metal parts production, investment, cast CNC machining, and DMLS are all visible technology. We summarize the advantages of each manufacturing month as following. It is critical to notate that final parts geometry is determined which month is most suitable way. So this is a generally guideline for decision making. About the DMLS is a powder bed fusion technology. It is widely applied to produce metal parts with high dimensional accuracy. The, this technology is able to create parts with very complex geometries design. Its design freedom encouraging it to be adopted by many industries like automotive and aerospace. While with optimization and excellent performance and critical, the MLS can produce parts from a wide range of metals like aluminum and stainless steel, as well as for competitive metal in the and medical industries like aluminum. The main limitations of the MLS are the high cost, small build size at long leading time, and the MLS parts also need support structures to reduce the likelihood of distortion and warping and must be removed after printing. About investment casting applied Wix pattern to create a model for casting. It has a clean burnout without any residues. So it includes the following process like 3D print pattern and model assembly and shell building and burnout and pulling and connect off and cut off and finished part. So for low value investment casting, normal parts are machined for weeks blocks by CNC machining. For large series, the die models is machined by casting weeks by the die. Molding is a very expensive investment as the production will take a long time. So 3D printing is regularly applied in continual with investment casting applications. In order to produce pattern-forming casting materials, castable 3D printing is common in defense and engineering industries. The normal process are SLA and this with photo polymerization technology can produce parts with very smooth surface and extremely fine details. So next, today my introduce is go the end. So next, my partner will introduce the next. So welcome to my partner Lucy. is automated, however, unlike CNC machine, it's more suitable for a simple design. 3D printing is the opposite of subtractive manufacturing, which is cutting out, hollowing out a block of material with, for instance, a milling machine enables you to produce complex shapes using less material than traditional manufacturing methods. While we use 3D printers for rapid prototyping, in short, it's fast and relatively cheap. From idea to 3D model to holding a prototype in your hands is a matter of days instead of weeks. Iterations are easier and cheap to make, and you don't need expensive models or tools. Besides rapid prototyping, 3D printing is also used for rapid manufacturing. Rapid manufacturing is a new method of manufacturing where business use 3D printers for short-run, small batch customer manufacturing. Last is sheet metal. Sheet metal manufacture is the process of creating sheet metal parts by cutting, bending, and forming thin metal sheets into specific shapes and size. The process typically uses coating, cutting, bending, and assembly techniques. Sheet metal is made from various materials, including steel, aluminum, zinc, and copper. It can be as thin as a few thousandths of an inch or as thin as several millimeters. Sheet metal parts are used in cars, buildings, airplanes, and other appliances. The manufacturing process starts with selecting metal and cutting it into the desired size and shape. The metal is then formed into its final product through various techniques such as rolling, extruding, and bending. The end product can vary from simple flat panels to complex three-dimensional structures. Following the techniques outlined below, the sheet metal fabrication process works effectively, and produces top-quality results. Manufacturers can use a variety of machines for cutting sheet metal, including those specially designed for fabrication work. Laser cutting is one of the most common methods of sheet metal cutting. A laser cutter uses a laser amplified by a lens or mirror to cut through thin to medium sheet metal but difficult into the most challenging materials. Wood jet cutting is a technique that uses
high pressure water to slice through metal. The wood jet is especially useful for cutting low melting metal since it doesn't hit the metal enough to deform it. Plasma cutting creates a channel of unzip gas that can easily be cut through thin sheet metal. Plasma cutters are less precise than laser or water-jet cutters, but they are fast, efficient, and have low setup cost. The above three cutting machines can be used for sheet metal and other materials, but different methods are also available for sheet metal fabrication. For example, punch and die to create precise holes in sheet metal. The sheet metal is placed between the two pieces, one of which has a hole at its center. When the punch hits the metal, it pushes the hole through to meet the other die's hole. The result is a punched load of removing material that can be used as new blanking. If multiple holes are desired, the same equipment type can be used to make them. Sheet metal deforming process involve changing and meshing sheet metal without cutting it. Bending is one of the most critical forming process, and it can be done using a brake machine. A sheet metal company can use this tool to bend sheet metal into BU and channels up to 120 degrees. Thinner sheets are easier to turn. This is because they are less rigid and have great flexibility. The reverse is also possible. Sheet metal fabricators can remove horizontal shaped bends in sheet metal by straightening the metal by removing small portions at regular intervals. The stamping process is another deformation process, but can also be considered a separate subcategory. A hydraulic or mechanical punch press with a tool and die is used to deform sheet metal in the stamping process. The process is similar to punching but does not remove material necessary. Sheet metal stamping can be used for specific tasks such as drawing, hemming, and more. The spine sheet metal fabrication process uses lasers to press the metal against rotating tools. The process is similar to CNC or pottery and helps make road parts like cylinders, corners, and more. In addition to bending, other methods of sheet metal include rolling, which is used to create complex bands in sheet metal, and rolling where sheet metal is fed between a pair of rollers to reduce thickness. Some processes combine cutting and forming. For example, the sheet metal expansion process involves cutting several metal slots and then expanding the metal. What are the advantages of sheet metal forming? Sheet metal forming has a Sheet metal forming has a number of advantages and benefits. Here are some advantages of sheet metal forming. The first, relatively inexpensive when compared to other manufacturing processes such as casting or forging. 2. Very flexible in terms of design and application. Sheet metal can be formed in various ways with a wide variety of metals in order to produce a wide range of parts. 3. Sheet metal parts are extremely durable with good tensile strength and environmental resistance. 4. Suitable for producing small batches, which makes it ideal for rapid prototyping. 5. The use of thin sheets of metal makes sheet metal parts lightweight, while still remaining durable. This is ideal for applications in which a high strength-to-weight ratio is required. What are the disadvantages of sheet metal forming? Sheet metal forming does have some drawbacks. Here are some disadvantages of sheet metal forming. 1. To start manufacturing with sheet metal forming, a high initial investment is required to acquire the necessary equipment and tooling. 2. Very complex designs can be unsuitable for sheet metal forming and result in higher cost and production times. 3. Sheet metal forming is a fire labor intensive process with many manual steps. This can make it slower than other processes such as stamping. Which industries typically use sheet metal forming? Sheet metal forming is used in an incredible wide range of industries. Thanks to its versatility, relatively low cost, and the durability of the produced parts. Some industries that commonly use sheet metal forming are automotive, use sheet metal forming for body panels, chassis components, and other structural parts of the vehicles. The durable, lightweight components produced by sheet metal forming make the mast an ideal choice. Aerospace use sheet metal forming due to the general precision of the forming process, along with the high strength to weight ratio of the produced parts. It's commonly used for fuselages and structural components in aircraft and spacecraft. Construction makes use of sheet metal forming to produce durable, weather-resistant components such as roofing sheets, structural components, and ductwork. Medical equipment, housings, and enclosure for medical equipment, as well as medical devices, are commonly made by sheet metal forming due to its ability to meet stricter standards and requirements. Household appliance. Sheet metal forming is commonly used for making enclosures, framers, and other structural components used in household appliances due to its precious and durability. This process can manufacture rapid prototypes. If you are interested, if you have some new project in this process, you can contact us. Noble, we have Noble, we have two major business direction. The first we can make parts by these three process. We can providing customers with project supporting service, including parts, machine, and manufacturing.
这里显示了时间，然后有时候显示直播，有时候又显示那个，不知道。
奇怪，可能网。